Hello, everybody. Good afternoon. Okay, so we'll start the session. Sorry for this short delay. We had some technical issues, and we'll may have to change the schedule a little bit. So welcome to this session on semantic interoperability and FAIR semantics. I'm actually going to switch to presenter mode. So the idea of the session of today is to actually, raise awareness on the ongoing development related to FAIR in various projects, at least in Europe, to link FAIR, linking OntoCommons and the people participating in OntoCommons with FAIR-related initiatives, and to identify areas of collaboration and potential integration of relevant project outputs related to FAIR. So that's an activity we started at the beginning of the project, and actually the idea was to integrate and then make sure that what we're doing is aligned with the FAIR principles and the existing implementations. So I'm gonna give a very quick intro because we have one of our speakers, Danielle, who will need to leave soon. So just a reminder of the FAIR principles. This is a solution to enable data-driven science. The idea is to transform data into machine actionable unit of information. You have 15 principles that are detailed in the paper on 2016, in which basically interoperability is at the center of this work. And you can see here in the principles I2, for instance, that basically you need to use vocabulary / ontologies that should follow themselves the FAIR principles, which means that if you start thinking at the level of vocabulary and ontologies, well, that means you need to start talking about how these ontologies and vocabulary should interoperate. So this issue of semantic interoperability and interoperability in general has been discussed a lot in different contexts, and in particular in the European Open Science Cloud context, because EOSC aims at enabling a web of FAIR data and services for science. So basically, well, this is a hot topic. How do you make sure that you build an infrastructure that is interoperable and rely on FAIR principles? And in the earlier days, like 3 years ago, there was a working group on FAIR and architecture, which actually came up with a document that's called EOSC Interoperability Framework, to which I make a link to the document, in which they identify 4 levels of interoperability: legal, organizational, and technical, and semantic. They do provide some definitions that they've been taken up from other initiatives. The first one is semantic interoperability ensures that the precise format and meaning of exchange data and information is preserved and understood through exchange between parties. In other words, what is sent is what is understood. And this is a definition that is provided by the European Interoperability Framework, developed by the ISA² program, which is a joint European program for harmonizing governmental data, publication of governmental data. The other interesting definition that is, for me, complementary is the one coming from the FAIR project, where basically they mention that semantic interoperability is the ability of computer system to transmit data with unambiguous and shared meaning. And the most interesting part is that this semantic interoperability is a requirement to enable machine computable logic, inferencing, knowledge discovery, and data federation between information systems. Within this work, the working group established a conceptual framework in which they highlight different components. And here I'm going to focus on 3 main components. The semantic governance component, which should be aligned with the FAIR principles, but actually contains a module which is called Semantic Interoperability Agreement, which is basically the idea is that in order to achieve semantic interoperability, people need to agree on how to represent semantics. And that's actually related to what was discussed this morning, for instance, in the bridge concept and the different ways of aligning the different ontologies. The second component is what they call the semantic business object, which contains the list of semantic artifacts, and I'm going to provide a short definition after that, and also metadata, data models, control vocabularies. And then a third component, which is of interest, which is the semantic functional component, which include metadata catalog, semantic artifact catalog, and mapping repositories. Of course, this work was just a foundation for further work that is actually continued in the context of EOSC through the Semantic Interoperability Task Force, which started end of summer 2021, I believe, and that is going to be presented today by Walmart. Then, if we start looking at the problem of the semantic business object, well, it was said in the FAIR principles that this object must follow FAIR principles. And if you start looking at the landscape of these resources, you realize that, well, they are hard to find, hard to reuse within and across domain, and they have tons of interoperability problems. So currently, the whole semantic landscape that includes ontologies and vocabularies, thesauri, and various different objects is currently not fair. And for that reason, there was the project FAIR, which is now finished, which started to work on establishing recommendations on how to make this object fair. And here, in that context, in the context of FAIR, there was a definition which is very important: the semantic artifact. The semantic artifact is defined in this work as a machine actionable and readable formalization of a conceptualization, enabling sharing and reuse by humans and machines. So these artifacts may have a broad range of formalization, from loose set of terms, taxonomies, thesaurize, to higher order logics. Moreover, they can be serialized in wide variety of digital representation formats. The idea of this concept of semantic artifact actually raised up in the project. It's like a bridge concept. The idea was to actually link different view of the world, different ontologies on ontologies and control vocabulary, and avoid endless discussions about what is an ontology and what is not. And it was used actually to help communicating and working in this project. And in the project FAIR, the idea is that semantic artifacts are considered as data and not as just metadata. So there is a seminal work, the third version of recommendations that's been published. There are 17 recommendations and 12 best practices that have been aligned with recommendation RFC 2119, which means that we have mandatory, recommended, and optional recommendations of 9 mandatory, 7 recommended, and 1 optional. And these recommendations were not built in the corner, in our own corner, but through a lot of workshops we organize, engages with multiple communities. They also reused some of the work that were coming up from the communities that are listed here, including the IOF principles and the Obo Foundry, which were our initial inspiration. Now, we do have a sort of formal context to make ontologies fair. Now, that relates in practice to how do you evaluate the level of fairness. And so basically in the context of FAIR, OntoCommons, and now the FAIR Impact project, there is some work that is going to be presented by Danielle right after I finish my presentation about the idea of aligning the different tools that exist and that are currently using different assessment grids. And I providing you some reference to the landscape analysis we did in OntoCommons, where we kickstarted a little bit this work and compared two different evaluation methods. Now, this FAIR project is finished, the recommendations are still there, and there is a follow-up project that's called FAIR Impact that is going to be presented later, And in this project, the idea was to reuse or to actually continue some of the work we started in FAIR about specific recommendations. And in particular, the fact that if you want to document your ontology and you want to establish whether or not this ontology is fair, you need to define a common minimum metadata schema to describe semantic artifacts and their content. That minimum metadata schema is then going to be used for the fairness assessment to determine whether or not you're fair. And the two other recommendations are focused on mappings, because we've seen that in this workshop, there are different kinds of mappings. We see the mappings between the top-level ontologies. We have been discussing about bridge concept this morning as well, which are sort of mappings between different elements. And these mappings should themselves be fair because they do contribute to the semantic interoperability landscape. So the idea of the session today, and this is the agenda for today, I'm going to stop talking. I will leave the floor to Danielle to kickstart a presentation on evaluating fair compliance for semantic artifacts. Then we'll have a presentation of Robert Pergel on minimum metadata for fair semantic artifacts. And then a presentation from Jana Martinkova on fair mappings. And then we'll conclude with a presentation from Volmar on the EOSC Semantic Interoperability Task Force. And then whenever we get the chance, we'll have discussions about how to actually leverage these different outputs and connect. So enjoy the session. I would like to give the floor to Danielle.
Thank you, Jan. Let me try to. Can you hear me properly?
Danielle, you can share your screen.
Yes. Can you hear me?
Yes.
Okay, excellent. I'm trying to share my screen. All right. Can you see my screen now?
Yeah.
Excellent. All right. So I'm sorry because I have to give the presentation a little bit rushed since I have to jump into yet another meeting right after my presentation. So I am afraid I will not be able to stay for the discussion, which I regret. So my name is Daniel Garijo. I'm from the Ontology Engineering Group at the Universidad Politécnica de Madrid. But today I'm going to be speaking on behalf of a group of people, including Jan, by the way. And these are Maria Poveda Villalón, also from this institution, Emna Amdouni, Arcopol Sarkar, and Clement John Kent, and others as well, which have, this is an ongoing discussion that we are having as part of the FAIR Impact project. I don't think I need to add a lot of motivation for why do we need semantic artifacts to be fair, but I wanted to reflect a little bit on some of the experiences I've had in the past, right? In research articles, for example, I have encountered in many times that the ontology is sometimes just a picture and therefore not machine readable, which is great because it gives you an idea of what they use to represent the information, but well, I cannot reuse it, right? Because it's I cannot use the URIs of the ontology because there is no URI associated to any of the concepts. Alternatively, I've seen people also sharing their URIs with HTTP, their own server / their ontology, but when I've clicked on them, in many cases, it was not available anymore because unfortunately URL rot means that many of the links that we put in papers, especially when they are not non-permanent ones, stop being available after a while. And finally, another very typical example that I find, unfortunately this is way more common than I would like, is that sometimes you see the schema in the of the ontology in the paper, you click on the URL and yes, you get some classes, but the classes are not documented and they do not have any examples or the properties have not even labels, and that makes it really difficult to use. So I hope that with these three examples, I have motivated that semantic artifacts should be treated as first-class research outputs as well. I put here some of the initial papers that started the discussion on aligning the FAIR principles to ontologies, and Jan has also provided an overview of the efforts that culminated in some recommendations that are quite useful. So when assessing the fairness of a semantic artifacts using Jan's definition, we have faced several challenges, right? The first one is how the metadata is defined, because you have general versus community-specific metadata. The general metadata may be something, like the author, license, etc. But then at some points there are community-specific metadata that is used for labeling or defining terms in a very specific domain or group of people. So you need to have those into account. In addition, you also have vocabulary reuse, different practices, right? So there are heterogeneous practices. In some cases, you may use general vocabularies for doing annotations, or like Dublin Core for stating who the authors are, versus community-specific extensions that people use, for example, I don't know, to do something very specific in a given domain, like biology, right? Then you also have the notion of the intrinsic versus extrinsic metadata. What does this mean? Well, ontologies fortunately bring in a mechanism in which you can define the metadata of the ontology in the ontology itself, which is great. However, there are also registries of ontologies which include explicit extrinsic metadata, that is a metadata that is defined outside the ontology, and it's just available on the registry itself. So when you download the ontology, sometimes not all the metadata is there because it was in the associated registry. And finally, you get also the availability on content negotiation, which is, different people use different practices. For instance, I love following the linked data principles and make the ontology available on a URI and do the content negotiation through it, right? And then we have another challenge, which is that there are different tools for FAIR assessment with different scope. Some of the issues that we were finding is that it's kind of difficult to compare their outputs, and therefore we had to start aligning them to make sure that people get consistent evaluation results. So we are in the process of defining a new methodology for FAIR assessment, following some of the outputs from our own research group and the ontology engineering group. There is an existing methodology for designing ontologies, which is called the Link Open Terms Ontology, LOT. And the idea would be to extend this methodology to include an explicit box for FAIR assessment that is part of the methodology itself. So you have first there, how do you gather the requirements for the ontology, then how you implement it using Protege, how do you publish it with its corresponding documentation, and then the idea would be to extend this with an additional box, which is for FAIR assessment, right? There is a slight overlap with ontology evaluation, which is a current activity that we do. But while ontology evaluation includes more pitfalls and anti-patterns in the implementation design of the ontology, the FAIR assessment is pure compliance against the FAIR principles. And this is how it would look like in detail, right? So it would come right after of the ontology publication, because for FAIR assessment you need to have the ontology as a living artifact on the web. And then the methodology, what we have so far is that you need to choose a metadata profile to indicate the level of granularity at which you are, or your community is interested in assessing that semantic artifact. Then choose different assessment tools and tests that you are interested in applying for assessing your semantic resource, and finally obtaining a FAIR assessment score. So usually these two are associated with one of the existing tools that already exists for FAIR assessment, right? And what we have been doing as part of our impact in order to make sure that this methodology comes to life is that we have been working on three main things. The first one is a metadata landscape analysis to make sure that we can choose the metadata profiles that are appropriate. The second is producing a benchmark dataset that allows to test all existing tests that are defined for assessing ontologies in a fair manner. And finally, we have been conducting a FAIR assessment harmonization between the different tools that are part of the mini working group that we have for assessing semantic artifacts. So I'm going to be briefly talking about each of these. For the first one, which is the metadata landscape analysis, what we have done is that we have taken existing work, in part some of the collaborations by Jan and Clement, and we have gathered all the ontologies we could find from several existing registries like BioPortal, the Leak Open Vocabularies, LOV, OntoPortal, Describo, Prefix.cc, w3id.org, which is a place for defining permanent URIs and commonly used for defining taxonomies and ontologies. And then we have tried to gather all these scores, vocabularies, and semantic artifacts that are associated with each of these URIs, generating a metadata summary for each of them, and storing them in a knowledge graph so we can create different statistics. And this is an example of the work in progress. We have a first version of this analysis, which includes a little bit over 2,500 resources. So I'm crossing the second one because this is an annotation that we added artificially, but the other ones are like the common annotations that usually appear in these concept schemes or ontologies, right? So for example, versioning information is quite present on ontologies, not that so much in concept schemes, but you have importing many of these ontologies and concept schemes import other ontologies. They are labeled with labels that in different languages. They have licenses, title creators, and there are many more. I think there are, I can't remember, but there are more than 200 different properties that are used in total. So the idea of using that is work right now towards grouping some of these properties that are the same, like the schema.org/name is very similar to the title of the ontology, and therefore we can group them together and see how much these two properties have support across the whole corpus that we found, and generate mappings as Jan was suggesting. The second topic we were working on is the benchmark dataset. So a benchmark dataset is necessary to assess the completion or how realistic each of the tests that we are suggesting as part of the FAIR methodology are among all the vocabularies. Because if we see that we have a very representative benchmark, but no vocabularies within that benchmark pass that test, maybe we need to rethink the test a little bit, right? It may be very well aligned to the FAIR principles, but we need to take into account how realistic they are. This is a sample of the current version of the benchmark, which is still is work in progress. And what we are gathering for each of the semantic resources added to the benchmark is the ontology URI, domain, complexity, number of classes, what is the source and registry where this is published, and then things like the publisher to know whether this is a project, this is a standard, and so on. The serialization, sorry, the level of expressiveness that everyone is using, and so on. So we are slowly growing this benchmark in order to be able to use all these resources for assessment purposes. And finally, we are dealing with three different tools, gathering their inputs and outputs, and how to align the different tests that each of the tools have been applying to the different semantic artifacts, right? So we are considering three different tools, which are FOOPS, which is like the ontology pitfall scanner for the FAIR principles, or FAIR, which is a tool focused on BioPortal, and the FAIR Checker, which is a recent tool for 2023, but that does not have within its scope only ontologies, but also datasets, right? So the scope is a little broader. So the idea is that you have like a broad general tool, a tool that is a little bit more specific, but doesn't go like very much in detail, which is FOOPS, and then a tool that really digs in all the meta properties that you have assigned, which is OFAIR. And this is the process that we are undertaking right now to establish a common methodology to gather what are the different tests proposed by the tools, categorize these different tests, and then let the user choose what is it that they are most interested in when assessing their semantic artifact resources. And that's, I think, pretty much it. So if there are a couple of takeaways from this small presentation, is that we really believe that semantic artifacts should be treated as first-class research outputs, basically as important as a dataset or a software tool. And fair assessment requires selecting which metadata profile you are interested in and harmonizing tool output, which is work in progress that we are doing. And stay tuned, because by August 2023, we are going to produce a first milestone of the full methodology with the full metadata profiles, hopefully with an initial version of the mappings, with an initial proposed benchmark, which I hope the community will be keen on growing, and a first set of harmonized results from three different assessment tools, which I mentioned, in order to make sure that we can get a comprehensive response for example, all the elements in the benchmark. And that's it. Thank you very much. I'm not sure whether there are questions now or we should wait, Jan.
Thank you very much, Danielle. As you have to go, maybe we can take some question now. Is there any question for Danielle?
We have got one question from Robert Rovetto,
Mm-hmm.
but I believe it was more about your presentation, Jan.
Okay.
So he's actually asking this. For a living catalog or definitions of semantic interoperability. Oh no, sorry, it was just commenting. He said that he's also let's say creating a living catalog of definitions of semantic interoperability and for ontologies and variations. So in case someone is interested, you can also get in contact with him for more information.
Thank you, Robert, for sharing that, and thank you, Rita. Is there any question from the audience in the room? If not, then maybe we can move forward with the agenda.
All right.
Thank you very much, Danielle. I know that for accepting to give that presentation in that schedule and to be actually
Thank
late.
you. I just realized that I had my camera turned off. I didn't know that. I apologize for that. I usually like to present with my camera turned on. So I really apologize for that. I did not realize. So if anyone is interested in a copy of the slides, or you come up with a question afterwards, please feel free to contact me. I will leave my my email in the chat. Thank you.
Thank Danielle. Thank you. Okay, so now we've seen one of the aspects that I presented very briefly and quickly, so we could get Danielle to stay for giving this presentation. Bye, Danielle. So fairness assessment is important, and especially harmonization of it is important, because if you start having too many tools that actually are providing you different results, even though very similar, you cannot compare, it's problematic, because you cannot really know whether or not your resource is fair, or you may just pick the tool that actually fits your purpose, which is to say it's fair, not meaning it's in the end fair. So this work is important. It was started in OntoCommons, and then it's now continued in FAIR Impact. And as you have seen, well, in order to assess fairness, you need to define metadata. So Danielle is presenting the metadata analysis across a large corpus of ontologies to actually identify commonalities. What are the most common fields provided? Now, there is another work that is going to be presented by Robert. So Robert Pergel, who's going to talk about the work we did together in FAIR on defining a minimum metadata schema for FAIR semantic artifacts. Robert, the floor is yours. Well, work that is continued in FAIR Impact, really.
Thank you, Jan. Good afternoon, everybody. Can you hear me and can you see my screen, please?
Yeah, we can see your screen.
Excellent. Thanks a lot for the confirmation. So my name is Robert Pergel. I am an associate professor at Faculty of Information Technology, Czech Technical University in Prague. And I also work with Jan in eScience Data Factory as the lead architect and developer. And today I would like to speak a little bit about the effort of defining common minimum metadata for FAIR semantic artifacts. So I will give a little brief motivation and background, present the results of these efforts, along with some first application of them, and then some conclusions. So Jan already introduced the FAIR project, so there's no need now to explain more. So this is just a grounding, and what I would like to stress here is the machine actionable and machine readable formalization. My presentation will be a lot about that, because also along with what Daniel shared, the machine actionability and readability of semantic artifacts is really key for processing by machines and for higher reusability. So in this task 2.2 in the FAIR project, it was dedicated to establish prerequisites for better semantic interoperability by developing recommendations and facilitating uptake of good practices to make semantic artifacts compliant with the FAIR principles. And there was specifically recommendation number 3, a common minimum metadata schema must be used to describe semantic artifacts and their content. So what does it mean? FAIR semantic artifact. So here in the context of FAIR principles, is mostly principle F2. Data are described with rich metadata. And then the reusability principles 1 to 3. So there is clear and accessible data usage license. There is detailed provenance, and also they meet domain relevant community standards. But also interoperability is of course important, and in this respect the use of a formal, accessible, shared and broadly applicable language for knowledge representation and vocabularies following the FAIR principles are important to be taken into account. And now the key challenge is what, of course, as with every implementation of FAIR principles, what does it mean, rich metadata? So there are generally two approaches. Either the rich metadata can be really very broad and like a maximum amount of what can be said about a digital object. But of course, then it's hard to make people fill them, use them, and also sometimes collect them. This is why minimal metadata model is a good approach to start making things fair, because then it enables to agree on some very small, relatively small set of attributes that everybody can put to the metadata, and thus have a community agreement on the metadata model. So in this situation, this was the metadata for semantic artifacts, and it was a collaboration with a wide range of communities, and it resulted in the first version of the model presented here. So what was the result? So the minimal metadata model here is consists of two subsets of attributes. First is generic metadata properties for digital objects, such as creator, identifier, license, that are should be applied to almost all the digital objects, not just semantic artifacts. And then specific properties for semantic artifacts that are not then common for other digital objects, such as representation, language of the ontology, or used engineering method, and so on. So as for the methodology, the basis was MOD, that is that takes this maximum approach in the project since the release of 1.4 2019, and currently mod 2 from 2020. There are like more than 100 properties collected that could be used to describe semantic artifacts. So this was a very good basis to start from. And then multiple workshops and meetings of FAIR Task 2.2 group were taken to agree on the minimal metadata model. Also, there was a collaboration and support by the RDA vocabulary service interest group, ontology metadata task group. And these efforts were crowned mainly in the workshop June the 4th, 2021, where voting on the minimum model took place. And the voting was divided on, please tell us if a certain property should be optional, recommended, or mandatory for a simple use case. This use case was what would be the necessary fields for retrieving semantic artifacts. And mod 2 plus decat properties were offered and voted on. This is the basic, the ground meta model of model or excerpt of the model of mod 2. So from this model, the properties that have been defined and voted upon were for the semantic artifact, so mod semantic artifact and mod semantic artifact distribution, both being subclasses of the DCAT2 cataloging model. So mod semantic artifact is a subclass of DCAT dataset. And then there is DCAT distribution, and mod semantic artifact distribution is a specific subclass of this distribution. So these were the two main classes that the participants focused on, and how the votings were processed. So the participants were asked just to vote on the properties that they felt they have sufficient expertise and awareness to make an informed contribution. So then in the end, there were not like full number of votes for all the people, for all the properties. And in case one of the option of an endorsement level got the same number of votes, the less restrictive was chosen. For example, if the same number of people voted for mandatory and recommended, then recommended has been chosen as the less restrictive one. Also, we calculated an auxiliary informative metric called consensus that generally speaks about how what was the divergence or convergence on the choice. For example, in the table below, you can see that the CT title was almost anonymously voted, so it has high consensus, while some others then have lower consensus. So in the end, 41 semantic artifact properties were chosen, and 24 semantic artifact distribution properties were chosen. Roughly 1/3 of them are mandatory, 1/3 of them are recommended, and the remaining are optional. Then I was stressing the importance of machine actionability. So the next task was to encode the minimal metadata model into machine actionable representation. And the requirements for that representation were to be able to get the list of properties of semantic artifact and semantic artifact distribution, get definition of a property, and get endorsement level of a property. So all the important information that the machine may need to be able, for example, to generate a form in the UI to ask for these properties. And we took two approaches with some pros and cons. One was OWL-based approach, and second was the Shackle-based approach. So as for the OWL-based approach, it uses RDF OWL, object properties and annotations. It uses these constructs to define the list of properties, provide the definition and the endorsement level. The nice thing is that you can use Sparker to retrieve the information. You can just store the machine actionable OWL in the triple store and then retrieve this information. The drawback is that the OWL language meta description limitations led to a complicated non-standard OWL conceptualization because we needed to make an extra wrapping layer over the original properties to be able to map them and speak about their meta properties. The second approach, the shackle-based approach, is based on shackle shapes, which is a W3C standard for describing RDF graphs. And it's generally like a meta level where you don't touch your original graph, but you describe how the constraints about how it should look like, which is exactly what we wanted. So it enabled quite a straightforward specification of the list of properties. You can see the example on the right, some excerpt. So you can easily specify the list of properties. You can specify their minimum count, maximum count. So you give the multiplicity. However, the endorsement level recommended had to be implemented as an extension of the shackle, as you can see here. There's a endorsement, and so some extra vocabulary that's not a part of the standard shackle. And also, another drawback is that the description of definitions of the properties, they have to be copied extra to the shackle. While in the previous approach, you can just say what is the definition triple or definition statement. Usually it is RDFS comment or something similar. So there is RDFS defined by statement which points generally to the definition, and you don't need to copy paste it anywhere. You just point to it. So in the shackle, you need to make a copy paste. Also, this extension of the shackle may make problems with some tools because then they may complain that the shackle is not valid. But for custom-made tools, that should be no problem because still this is valid RDF. So now there is already an application that uses this machine actionable minimum semantic artifact metadata. This is called FAIR, and it's a proof of concept application developed by eScience Data Factory. It is based on the federated FAIR data space, and it demonstrates the potential of this common minimum metadata for FAIR semantic artifacts. Its main selling point is that it can be used to increase fairness of semantic artifacts without any time and resource investments at the side of repository providers. Because it's nice to have a new recommendation for the metadata of semantic artifacts, but then the adoption would mean that all the repository owners would need to implement it in their repositories, which would be ideal, but it takes time and money, and so cannot be expected to be immediate. While the FAIR is a solution that can, in the meanwhile, also with other benefits, give you immediate FAIR semantic artifacts without any collaboration needed from the side of the repository providers. And this implementation utilizes the first version, first variant, the OL-based semantic DCAT application profile. So it is the architecture in a sketch. So the input, there are two types of inputs. There is API and repositories description. So you provide, for example, description of the API of BioPortal. How do you access the list of artifacts? How do you retrieve individual artifacts? And based on these descriptions, then FAIRCAT is able to to automatically harvest the needed information. So it generally can harvest the existing metadata. And then based on the mappings that you provide, mappings between the semantic DCAT and the current metadata of the repository, they can be transformed into this representation of the common minimum metadata and published. And in this proof of concept, we used the FAIR data point, reference implementation of FAIR data point from FAIR Foundation, where the FAIRCAT API server then publishes the metadata, and they are available through the web client, but most important through the REST API, fully semantic RDF. And by this approach, you can generally also harvest multiple semantic artifact repositories and have them in one place in a FAIR data point. So for example, if you are doing research or based on some topic, you can collect all the metadata of the relevant repositories and be able to search them. And there are numerous other possibilities how this can be used. We are just like exploring and continue the implementation of this useful solution. Here I present it as a proof of concept of the application of the machine actionable profile. And in this situation, this was the generation of the automatic generation of the UI for the mapping between these repository metadata fields, which are on the right, and between the semantic DCAT application profile on the left. So this information here, for example, access rights, which is the information about who access the resource or indication of security status. These are populated automatically from the ontology. Also, you can see the red M, meaning the mandatory. Again, this is populated from the ontology. So when should the ontology change, for example, some community would make some of the fields more restricted or less restricted, or add some other fields also, then the code doesn't have to be rewritten. It's not hard-coded. It will just retrieve the ontology and rebuild the UI.
Robert, I'm sorry to interrupt. 2 minutes, because we're already out of time.
Yes,
sorry.
Thanks. So here is then the example of the result in the FAIR data point, as I mentioned. So this is the client, but as I say, the biggest benefit is in the FAIR machine actionability. So machines they can access the RDF representation of the harvested metadata. So conclusions, the summary. So here, the first minimum metadata profile for semantic artifacts was conceived. It was based on input from a large variety of communities. So we can call it a community standard, and aims to set a threshold below which an artifact can hardly be considered FAIR. So really minimum. And there was a focus on FAIR and machine actionability. So as for the future, The FAIR Impact project now builds upon that, mostly regarding the mappings that Jana will talk now about. And these machine actionable representation can be also used in other tools, for example, FAIR assessment tools. And the plans for future are to make the mapping semantic, and also to investigate W3C profile vocabulary to express the profile, and eventually use it to provide specification of a standard application programming interface that semantic artifact catalogs could implement. So here are the links to the paper preprint that has been submitted to a conference, but you can already check the preprint that contains all that I was speaking about and much more. And you can check the semantic DCAT application profile in the GitHub repository. Thank you for your attention.
Thank you, Robert, for this presentation. Is there a quick question for Robert? I don't see anything in the chat. Rita, is there anyone who has a question in the room?
No, as of now, we do not have any questions.
Okay, so maybe we can just move forward with the agenda. So the next presentation, so you've seen the approach on minimum metadata. FAIR principles are actually important, but sometimes there's things that are a little bit vague, like rich metadata. So we needed to fix a threshold for actually identifying when you reach the fairness. And we developed this FAIRCAT solution, which leverages mapping. And MOD, actually, the ontology we're using, is actually a lot of mappings between different ontologies. And now we have a presentation from Jana, who's going to introduce you the work we're doing actually in FAIR Impact together on mappings and FAIR mappings in particular. So Jana, and the floor is yours.
Thank you. I hope you can hear me and see the screen as well.
Yep, I can see your screen and I hear you fine at least.
Great. Perfect. Okay, so good afternoon, everyone. My name is Jana Martinkova. I'm from eScience Data Factory, and today I would like to present to you FAIR Impact project and our task in it that deals with mappings, crosswalks, and how to make them fair. Well, unfortunately, there is no unique definition of mappings and crosswalks. There are many related terms like ontology matching, which is finding relationships and correspondences, or semantic alignment, which is a set of correspondences between ontologies. But mapping in general is a process of establishing connections or relationships between different elements. It involves identifying similarities or correspondences and alignments. For example, let's say we have two different repositories. In one, the cat is called domestic cat, and in the other, it's a Latin name for domestic cat. We can say that the meaning is the same. And if we add a third repository where we have domestic animals in general, we can say that this term is wider than the term for cat. And these relations could be called mapping, which mapping that the example is in here is only one kind of a mapping. There are many other, like, for example, branch concepts, which OntoCommons does, or logical mappings of top-level ontologies. And why we want mappings to be fair? Well, most of mappings are not reusable for many reasons. If they are published and findable, very often there is no provided context about the mapping. And many existing mappings are based on community practices that sometimes requires additional information that could be, for example, another mapping. So we want mappings to be fair, so it will be possible to reuse them instead of duplicating the work again and again. And the fair mapping will lead to reduction of the computing power necessary to use the mapping, and it will also allow automatization of information retrieval. FAIR Impact is project. It's a European project founded by Horizon Europe program with the aim of expanding FAIR solutions across Europe and support the establishment of the FAIR European Open Science Cloud. We started with this project last year. There are in total 28 partners from 10 different member states. It's a 36 months project, and it's a sort of follow-up of FAIR's FAIR project. It's a coordination and support action, which means that our main objective is to work with people from different communities that are actually involved defining or implementing FAIR. So the goal is not to create something from scratch, but the idea is to engage with scientific communities to work together. The overall objective is actually to realize FAIR EOSC by supporting the implementation of FAIR enabling practices across scientific communities and research outputs at the national level. And how we are planning to do that? Well, we are planning to identify current and emerging components for enabling FAIR, whether it's practices, policies, or even tools or specifications if they exist. And we will try to gather available solutions, guidelines, or frameworks that have been developed from one domain or research output and support the application in other domains. And defining the support and governance for implementing the practices in EOSC. We have use cases from 4 scientific domains that help us designing these policies and testing them. And the 4 domains are agri-food, environmental, social sciences and humanities, photon and neutron sciences, and life sciences. In total, there are 7 work packages in the project, and the task we are working on is part of the work package 4, which focuses on metadata and ontology. The objective of work package 4 is to develop and foster the uptake of semantic framework for governance, creation, mapping, sharing, reuse, fairness assessment, and interoperability of semantic artifacts for EOSC. By semantic artifacts, we mean ontologies, terminologies, vocabularies, taxonomies, metadata schemas, and so on. And these artifacts are key elements to achieve FAIR, and they need to be FAIR too for that reason. The work is based on existing use cases, as I already mentioned, which is agri-food, ecology, biodiversity, earth sciences, astronomy, material science, and physics. And the idea is to implement FAIR practices around these metadatas and artifacts with these different use cases, so we can redefine the practices. Also projecting the FAIR principles to other types of research objects, which could be, for example, research software or crosswalks or mappings. In the work package 4, there are 5 tasks, and these 5 tasks covers the life cycle of semantic artifacts. So one task is on governance, one on lifecycle and catalogs, one is for research software, one on crosswalks and mappings, and the last one is on use cases in data repositories. We are working on task 4, which focuses on mappings and crosswalks. And our first objective is to understand the requirements for FAIR mapping, and we want to establish guidelines on how to make mappings FAIR. Secondly, to make the sharing of FAIR mappings easier, we will propose a common exchange model that will enable mappings to be more easily understood and being used by machines across each other. And this will enable a smooth exchange. And we want to extend SESAM model, which covers only subset of mappings. SESAM, for example, does not provide possibilities to express data mappings or metadata mappings in all range. Thirdly, we believe in the importance of collaboration with wider community, and by involving other researchers, data providers, and domain experts, we can gather valuable insights and feedbacks. And for the exchange model, and even for identifying methodologies and practices around mapping. To ensure the success of mapping process, we will work closely with task 4.1 of work package 4 to establish a robust governance framework. And this framework will focus on maintaining consistency, standardization, and quality assurance through the mapping process. For example, when the author of the mapping makes some modifications, how the users of the mapping will know the mapping is changed. Will it be still valid mapping or not? So these are the questions we want to deal with. At the end of this project, we want to deliver 3 main targeted outputs. The first one is specifications or requirements for FAIR mappings. The second one is a common exchangeable model based on SESAM that would enable share mappings in an exchangeable format. So different communities can use their own type of mapping, but if they are willing to share it, they can use the exchangeable format. So other communities can reuse it too. And the third output is a cookbook with practical guidelines showing the various ways of doing mappings, and the ways will be supported by concrete examples. Well, and how we are planning to do that? Well, we engage with different communities to identify methodologies and practices around mapping, and also to define, test, and adapt the exchange model for sharing FAIR mappings. We are organizing a series of workshops to engage with different communities to collect inputs, use cases, and information from them. We already managed to host a first workshop of this series. It was a very successful workshop, which took place in April with almost 120 registered participants from 24 countries. The participants come from 32 domains of knowledge and from almost 24 named organizations and communities. And many of them are willing to contribute to our work after this workshop. The main objective of this workshop was to start interacting with different communities to provide a place for initial discussion and to gather valuable inputs around 4 main topics, which were discussed during the workshop. And the topics were specification for FAIR mappings connected to FAIR principles, types of mappings, existing tools and requirements for tools, and mapping methodologies. We are planning additional workshops organized in various events like CyDataCon or RDA. And we are also planning a second workshop of the series during the autumn that will focus on how the mapping is done, what are the approaches, and what are the methodologies that are used. And other workshops of the series are coming on different themes. And I would like to invite you to join us in this workshop in autumn. And right now, we are focusing on the first version of specification or recommendations for FAIR mappings, and also on the first version of the FAIR mapping cookbook, as I mentioned earlier. And I would also like to invite you to join us and contribute to these steps. I think that's all for me. If you have any questions.
Thank you, Jenne. Any quick question before we move to Walmar's presentation, which will be the last presentation of the day? There will be a room after Walmar's presentation for interactive discussion and questions, but feel free to ask questions. I know it's post-lunch session, so it's hard for everybody to stay alive and fresh. Okay, so for now, I don't see any movement on the chat or any movement in the room. So I will thank again Jana for this presentation. Indeed, FAIR Impact just started, so we are now collecting things and we are starting to put things together. Again, so in OntoCommons, but in many other communities, there are a lot of work going on mappings. So of course, it's a call for contribution and for collaboration. We're also going to collect use cases. So if you have any use cases that you'd like to share on mappings, you're most welcome to contact us. And now I would like to move to the presentation of Wolmar on the EOSC Semantic Interoperability Task Force, where we're also talking about mappings, one of the topic. Wolmar, floor is yours.
All right. Can you see my slides? Hello, can you see my slides?
Yes.
Fantastic, thank you. So I have also shared a link to the slides deck in the chat, so please feel free to look into the slide deck online as well, because there are some links and some contact details that you might want to use if you want to follow up on anything. So I'm going to start with a short introduction of the context that we're working on. And it's in the context of EOSC, which is the European Open Science Cloud, and an effort to realize a web of fair data and services. So it's also a pilot action towards this European data space for science research and innovation. The EOSC Association is an organization that is supposed to represent the community's voice, and that is the research institutes and individual researchers across Europe in dialogue and procurements and funding of different projects realizing EOSC funded by the European Commission. And to do this, the EOSC Association has organized a few advisory groups, and they are organized, they have some subgroups that focus on specific topics. So these are called task forces, and they have worked for a little bit over a year, and they will be active until the end of the year, I think, most of them. The task force that I represent is focused on semantic interoperability. And it takes off from a report that was written called the EOSC Interoperability Framework. And this has also been the basis of several other investigations around interoperability and EOSC. And Jan gave a brief introduction to the framework in the beginning, or some screenshots from it at the beginning of this session. So the idea is that we are going to address some interoperability challenges that are more specifically associated with semantics and semantic interoperability. And there is some guidance that we can use from this EOSC interoperability framework, but in general terms, we want to work with vocabularies and crosswalks and how people encode information and exchange it across within and across disciplines. And the idea is that this is important to make sure that you have interoperability not only across, being able to open the tools in specific parts of software, but also being compatible across infrastructures and services in the EOSC ecosystem. And then also looking at where you can find these vocabularies and defining what a catalog of a vocabulary would be. And the last part that was defined in the charter is looking at interoperability in practice and scenarios or use cases and different solutions that have been found across projects and institutes. So the idea is that we're going to do a few thematic explorations to look into some specific solutions around semantic interoperability. We're going to work actively with knowledge exchange, participate in workshops, organize workshops, and kind of survey literature together to form an idea of what would be good solutions for cross-domain and inter-domain interoperability for EOSC. And then converge on a few recommendations that would be suitable regardless of which discipline you're working in. The task force is constituted of 40 members that are active to various degrees, and these act as liaisons to different EOSC projects and organizations across Europe. So we have used the members that we have and their engagement as the starting point for our activities. We have also organized ourselves into smaller groups that are looking into a few themes, as we call them. So one is focusing on metadata and data conventions, standards, schemas, and vocabularies and things like that, doing basically a landscape survey of the state of the art across different disciplines. We also have a group working on semantic artifact catalogs and how you could make these semantic artifacts available and govern these catalogs, and I mean what is a good definitions of a catalog. And then we also have a group working on use cases and collecting real world examples of solutions. The first team has been working on a landscape survey, and currently there is a proposal for a process of reaching out wider beyond the task force to the European and global research communities. So if you are interested, you can take a look at what the proposed process would look like. And there's also a conference contribution based on this process that will be public in the few coming days, I think. So you can follow the link and read more about that here. They are working towards some interoperability recommendations based on these surveys, converging on some minimum metadata and interoperability indicators that would be good for semantic interoperability. And then also an inventory of different tools that you can use to realize semantic interoperability. And that could range from mappings and crosswalks to tools and different languages that you can use to encode semantic artifacts. There's also some considerations for long-term sustainability of semantic interoperability solutions. And we would like to converge on some recommendations on that aspect. And it would be great to get feedback from the different active projects, since the task force itself doesn't have direct funding. It's in-kind contributions of the members and the projects that they represent. The coordinators for this theme is Kurt and Milan, and their contact information is listed here. You can reach out to them directly if you have any questions on these activities, or you could reach out to the task force as a whole. And Jan is also an active member, so if you know him, you can also get in touch with us. We are also working on a survey of semantic artifact catalogs, trying to answer to the question, what is a semantic artifact catalog, and what dimensions would be good indicators for maturity. And what you can see here on the right is a screenshot from the pre-reviews web interface, where they have currently a preprint in review, which is open for comment. And if you follow the link, you can add your own comments and review the preprint. This is based on a literature study and a review of a selection of catalogs, and both of these are also available and published on Zenodo, so you can get links to that from the preprint itself. Contacts for this is Jan, and then you also have Oscar and Silvio. For semantic interoperability use cases or journeys, we are working on capturing different case studies and use cases, and these are contributions either by task force members, but also some external contributions from projects that want to highlight their solutions for achieving semantic interoperability. The work that we aspire to do in this theme is to curate this collection of examples in a way that you can contrast and compare and identify some useful solutions that could inspire across different disciplines and areas of solutions. Before we close down our activities, we would try to find a representation across different communities to make sure that, I mean, we have found some examples of solutions that would be theoretically usable across of the entirety of EOSC. And coordinating this is me, and you can contact me using the information here. And the link down there leads to a presentation from the EOSC symposium last year, which is basically a pitch for why you would be using case studies or use cases to demonstrate semantic interoperability. And the last slide is some example here of how you could engage with the task force. So you can contact me or Oscar, which are co-chairs for the task force, and align your activities with ours. You can also interact with us at some upcoming events, and I've only listed 3 here as examples. So one is a workshop on ontologies and FAIR ontologies, then the EOSC symposium in September, and then we have the International Data Week, which is the RDA and SciDataCon event in October. But you can also feel free to reach out to any of the task force members and use them as a liaison to engage with our activities. And the link on this slide leads to a document which gives a very brief overview of some of the topics that we cover. And with that, I would like to say thank you. And you can reach out to either us as co-chairs or any of the members, as I said.
Thank you, Walmar. Is there any questions for Walmar? Any question in general, because that's the end of the session, so we don't have presentation. So you've seen there are different activities around FAIR. We actually missed one project, which is FAIR Core for EOSC, that was not mentioned today, but is sort of a sister project from FAIR Impact. Well, FAIR Impact is like OntoCommons. It's a coordination support action which aims at, putting together people, sitting down, discuss common matters, and try to converge on community agreed recommendations or specifications. FAIR Core for EOSC is a project that actually develops services, and in particular, they do develop a metadata or mapping registry, which goes along with the work we're doing in FAIR Impact that Jana presented. So basically, they are building the software. We are working to define the model that is going to be used by the software and the service. Now, FAIR principles, well, they are a very nice set of guidelines that doesn't necessarily give you solutions on implementing semantic interoperability. You just put it as a requirement, but it doesn't help you defining how to do that. So there are many different ways of doing it. OntoCommons is working on some aspects, and we know the communities are working on some of these aspects. So that's why we're also coming for contributions to this sort of survey we're going to launch to actually understand what are the different ways of approaching semantic interoperability. So of course you are most welcome to join and to contribute. Well, Rita, is there any questions or anyone who would like to actually make a comment or react on the different things that were presented in the room?
In the room, I do not see anyone that would like to make any comments, and also here in the chat.
Yeah, okay. So, well, it seems that our presentation were quite clear, and we left the attendees speechless. At least I hope that it was informative. So if there's no one who would like to discuss anything or no questions, maybe we can stop the session here, so that at least we recover the initial delays and people can go to the coffee break, I believe.
Actually, we're going to have another session that is starting now at 15. So as next steps, now we will close the room now, and we will open the room for the education and standardization session that is actually starting in a couple of minutes.
Okay. Well, thank you everybody for attending this session. I hope it was helpful and useful. There's my email on the chat, and you can always ask the colleagues from OntoCommons if you have any questions. We'll certainly share also the presentations. And well, see you maybe next time or in one of our different workshops we are going to organize. Enjoy Oslo.
Thank you. Bye.